Let's take a look at a definition of what an angle of elevation is. Many problems that can be solved using trigonometric ratios deal with angles of elevation. Definition of an angle of elevation is formed by a horizontal line and a line of sight above it. So if this is your horizontal right here, okay, this is your horizontal line, okay, and you have a line of sight above it, that's what we call an angle of elevation. This one is your angle of elevation, okay. And this is very important because in word problems you need to distinguish between angle of elevation and angle of depression, which we will be talking about later on, okay. Let's see how we use the angle of elevation to be able to solve real life problems. A hypsometer is an instrument that measures an angle of elevation. You can make a model of a hypsometer. You can probably do this at home. But right now, we'll just do this together. Okay? So, a hypsometer is made with, not that one, okay? A protractor. This is your protractor. Tape it on an index card, and this is a piece of straw, okay, plastic straw, and you attach a string with a paper clip to a piece of straw. What you want to do is you want to look through this piece of straw with one eye, and you can measure, another person can measure the angle, okay, by which the straw goes up. So let's say, for example, you want to measure the height of this tree, okay, and this is your hypsometer. You look through the straw, okay, all the way to the top of the tree, okay. Be sure though that you know the distance between you and the tree. In this case, it's 46 feet, and let's say the ground to your eye is 4 feet, okay. So you know more or less, you can now more or less measure the height of your tree from there, okay. In this case, the guy measuring the tree, okay, measured it using a hypsometer, and the angle of elevation is 35 degrees, okay. We will find out how we can measure the height of the tree, because remember, in our trigonometric ratios, we talk about the three trigonometric ratios of SO, CA, TOA, okay. In SO, CA, TOA, we now have this angle right here, and you are given 46 feet, okay, and you're given 35 degrees. You want to find this particular angle. So ask yourself, how is 35 degrees related to 46 and x, okay? And if you notice, the height of the tree is the opposite side, okay, of our angle, and 46 is the adjacent side. So knowing those two, okay, we know for a fact that this becomes your TOA ratio, or opposite over adjacent, and we can now solve for the height of the tree. Using TOA, that means we use the tangent ratio, okay. Using the tangent ratio, we have now tangent 35 degrees is equal to opposite side over adjacent, which is 46, okay. And if we want to solve for x, okay, we simply multiply both sides by 46. So you now have tangent 35 degrees, multiply that by 46, will be equal to x, okay. And tangent 35, let me check that, is 0.700. Multiply that with x, which is 0.46, which is 46 feet, will give us 32.210. Approximately equals x. Obviously, I use a calculator for this one, okay. So the measure of the tree is 32.210 from this point right here, from this point all the way to the top. So what do? We simply add, okay? Simply add now your height from the ground, which is 4 feet. And that will be the measure of the tree, or the height of the tree is approximately 36.21. Okay, from the ground. Take that out. 36.21 is the approximate height of our tree. And that's how you use that hypsometer to be able to find the height of the tree. Okay, and obviously our hypsometer is very crude. There are actually modern hypsometers you can put on your iPhone, and it can measure the angle and find the height of the tree quite easily. So if you look at our hypsometer, that's one way of creating a hypsometer without a lot of fuss. Okay, so let's move on and let's learn the concept. The trigonometric ratios and the Pythagorean theorem can be used to find the measure of any side or angle of a right triangle if the measure of one side and any other side or acute angle are known. What does that mean? Let's take a look at example number 1. Find the measure of angle J. This is angle J, okay, in triangle JKL. So we want to find the measure of this angle right here. Okay, the measure of the leg opposite angle J and the measure of the hypotenuse are known. So we use the sine ratio. Why do we use the sine ratio? If this is angle J right here, and this is the opposite side, and this is the hypotenuse, remember what we learned in the last lesson. Our trigonometric ratios follow, okay, SOHCAHTOA. Okay. And if you look at angle J, look at 5 and 8, you ask yourself, how are 5 and 8 related to angle J? They're opposite, and 8 is a hypotenuse, so we use the sine ratio, opposite over hypotenuse. And that's the reason why we use the sine ratio, because of that relationship. Okay? So from there, sine J is equal to the measure of the opposite side J and measure of the hypotenuse. Continuing this, we now have 5 over 8. Okay? 5 over 8, we replace the measure of the opposite J and the measure of the hypotenuse. Before we do that, okay, 5 over 8 as a decimal is 0.625. Therefore, J is 38.7 degrees. Now, how did we get 38.7 degrees? Remember, we need to enter 38.7 in a calculator and click on second sign to the -1, okay, to find the angle. Okay, we learned that in the last lesson. Okay, let's move on. That is example number 1, finding the measure of that particular angle. In example number 2, we discuss angle of depression. Remember, we talked about angle of elevation. Okay, in angle of depression, there's a good way to look at it. A person on a tower or a cliff must look down to see an object below. So the definition of an angle of depression is formed by a horizontal line and another line of sight below it. Remember, in our angle of elevation, okay, our angle of elevation is that we have a horizontal line and a line of sight is above it. Okay, so that's how our angle of elevation looks like. In our angle of depression, okay, our angle of depression, we now have our horizontal line right here and the line of sight below it. So this is our horizontal line and this is our line of sight, LS. In our angle of elevation, this is our horizontal line and this is our line of sight above the horizontal line. Okay, distinguish between the two, because once we get into word problems, that will make all the difference if your answer will be correct or not. Okay, which brings us to this example. Let me take all of these out first. There you go. A fire is sighted from a tower. Uh, a fire is sighted from a fire tower in the Black Hills National Forest. Using a hypsometer, the ranger found the angle of depression to be 2 degrees. If the ranger's eyes are 100 feet above the ground, how far is the fire from the base tower? Okay, so this is where it all comes in, but we need to be able to put it in perspective. What do I mean? We need to be able to draw it out. If you can't draw it out, if you can't visualize what's happening, it's going to be a problem. So this is what's happening. We let D represent the distance from the fire, okay, to the base of the tower. So this is the distance. If this is where the ranger saw the fire, D is the distance. Okay? So in the diagram, a line from the fire perpendicular to the horizontal line of sight forms a right angle. This is basically what it's saying. Perpendicular means right angle right here. And if D is the distance right here, okay, therefore D, you can also put D on top. Okay? So, therefore, both lengths can be labeled D, and that's what we just did. Notice that 125 feet is the length of the leg opposite angle 2. Why is it 125 feet? Because the hypsometer is 125 feet, okay, above the ground. The ranger's eyes are 125 feet above the ground, okay? That's the reason why you have 125 feet, okay? 125 feet is the length of the leg opposite angle 2, and D is the length of the leg adjacent to angle 2. The tangent ratio should be used to solve this problem. Again, why tangent ratio? Because you want to find the value of D, okay? And if we use this, 2 degrees, to find the value of D, what do we know? We know that that's 125, and we want to find D, okay? And in the tangent ratio, which is TOA, it means opposite over adjacent, opposite side over adjacent side. So basically, we are creating tangent 2 degrees equals 125 over D. Okay? And that's exactly what we have here. Don't worry about that jumping thing at the bottom. Take care of that later. Okay, so tangent 2 degrees is the measure of the opposite side. Measure of the leg opposite over the measure of the leg adjacent, tangent 2 degrees. Okay, you now have tangent 2 degrees equals 125 over D. We're simply substituting the values for that one. Tangent, and to be able to solve for D, okay, we multiply both sides by D first. And that's the reason why you have D times tangent 2 degrees equals 125. And to be able to solve, another step to solve for D is divide both sides by tangent 2 degrees. Okay, and this is a good way of computing for D. Okay, do not convert tangent 2 degrees into a decimal first, because this is a more efficient way of doing it. Okay, so you now have 125 divided by tangent 2 degrees. Now convert that into a decimal, and then get 125, divide that by the decimal of tangent 2 degrees. You end up with approximately 3580. So, what does that mean? The fire is about 3,580 feet from the base of the tower. And that's how we use our hypsometer to find out the distance of the fire from the fire tower. Okay? Okay, let's try these examples. These are in your guided practice. So what you can do probably is you can pause the video and solve it for yourself and see how I do it. See if my answer is correct or not. Okay? Or your answers are correct or not. My answers will probably be correct since I'm recording this. If it's wrong, I'm going to record over it. So that's it. Okay. Let's start. Number 4, write an equation that you could solve for x, then solve, round decimals to the nearest tenth. Okay, so you have a right angle right here, number 4, and the angle measures 46 degrees, and you have 15 feet and x feet. The first thing you need to ask yourself is this, okay? How are 15 and x related to 46? Okay, we know for a fact that 15 is the hypotenuse and x is the opposite side. Okay, so you have a hypotenuse and opposite side. Okay, let's take a look at our ratios and see which one fits. You have so, ka, toa. Okay, and we have opposite and hypotenuse. What ratio does it fit? Right here, opposite and hypotenuse. So we use the sine ratio. So get sine 46 degrees equals opposite side, which is x, over hypotenuse, which is 15. Okay? From there, we solve for x. In order to solve for x, we multiply both sides by 15. Okay, multiply both sides by 15. Let me take that extra line out of there. Let me rewrite that. Multiply both sides by 15. Multiply both sides by 15. Okay? And then we now have x equals 15 times sine 46 degrees. Get used to this thing. Okay? And using my calculator, sine 46 degrees times 15 is equal to sine 46 sine times 15 is equal to 10.79. Okay, let's say to round it to what number? To the what place value? It says round to the nearest tenth. Okay, so 10.79 rounded to the nearest tenth is 10.8. So the value of x is approximately 10.8 feet. That is for example number 4. Okay, let's take a look at example number 5 and see how this works. You have 39 degrees given and 10m and xm. Again, first thing you need to ask yourself, how are 10 and x related to 39? Okay, we know that 10 is the opposite side of 39 and x is the adjacent side. So using our trigonometric ratios, where do you have opposite and adjacent? Okay, opposite and adjacent is in the tangent ratio. So we use the tangent ratio. We get tangent 39 degrees is equal to the opposite side, which is 10, over the adjacent side, which is x. Okay, and multiply both sides by x first. So now you have x times tangent 39 degrees equals 10. And then divide both sides by tangent 39 degrees. Sorry, let me correct myself there. That's not x, that is 10. Right there. Okay, divide both sides by tangent 39. You have now x is equal to 10 all over tangent 39 degrees. Okay, using the calculator, okay, x over tangent 39 degrees. Let me get my calculator real fast. Okay, and x over 39 degrees. Okay, hold on. My calculator is the book. I don't have to punch it in all the way. It's coming. There we go. Tangent 39 degrees is approximately 12.3. Okay, 12.3. So the measure of angle x is approximately 12.3 meters. And lastly, let's take a look at example number 6. We want to find the angle x. Again, we ask ourselves, how are 12 and 16 related to angle x? So in this case, we know that 12 is the adjacent side of angle x and 16 is the hypotenuse. Okay, so if you look at our trigonometric ratios, go back to our trigonometric ratios, which ratio will have adjacent and hypotenuse in it? It'll be cosine. So we use cosine. X is equal to adjacent over hypotenuse, 12 over 16. Okay? And using our calculator, cosine x equals 0.75. Okay? And remember how to find the angle of cosine x. In this case, we click on second cosine to the -1 and then enter 0.75. X now will have the value of 41.4 degrees. So that is approximate value of x. Okay, remember what we learned in the last lesson, because that will be the foundation of what we're doing here today. Okay, and that's about it for this one. Write your summary on Google Forms, and questions that you may have for this lesson. Thank you.